So probability 1, the fundamental principle of counting. It states if one trial has m possible outcomes and a second trial has n possible outcomes, the letters they use are m and n, then the total number of possible outcomes is m by n. I think the best way to see this in action, if you imagine you're in a restaurant and there's 3 starters, which we'll call A, B, and C, and there's 3 mains. This restaurant doesn't do desserts. We'll call them D, E, and F. So how many possible meals can you have? Well, if we think about it like this, A, you can have with D, E, or F. B, you can also have with D, E, or F. And C, if you choose C, you can also have that with D, E, or F. So you can see here, 3, 3, 3. There are 9 meals, which is your m by n. Your 3 starters by your 3 mains is equal to 9. So take this down in your copy before we move on. So let's look at factorial notation. Factorial notation uses an exclamation mark. 1 factorial is just the number 1. 2 factorial is 2 by 1, which is equal to 2. 3 factorial is 3 by 2 by 1, which is equal to 6. 4 factorial is 4. You could write it as 4 by 3 factorial. You may see it like that, which is 4 by 3 by 2 by 1, which is equal to 24. And 5 factorial, 5 by 4 by 3 by 2 by 1, which is 120. Now you guys write down 6 factorial, 7 factorial, 8 factorial, 9 factorial, and 10 factorial for me before we move on. Okay, so you can see these numbers growing quite quickly. Set 6 factorial, you've written down 6 by 120 is 720. 720 by 7 is 5040. 5040 by 8 would be 5 8s or 40,320. 4320. If you multiply 40,000 by 9, you'll get around 362,880. And if you multiply that by 10, we're up into the millions. 3628. 3628,800. Little commas for my millions. So 10 factorial, up into the millions. Now, what would factorial be used for? Let's take the word math. We could put an S on the end and say maths, but America, they love the word math. High school math, right? So math. How many ways can we rearrange the word math? So the answer is 4 factorial. So if you put m in the first, which is 24, so you put m in the first position, there's 3 places for a to go, which would leave 2 places for t and 1 place for h, and we can do that 4 different times. We could have the a at the beginning, 3 by 2 by 1. We could have the t at the beginning, which would leave 3 by 2 by 1. And we could have h at the beginning, which would leave 3 by 2 by 1 for the other positions. So you've got your 6, your 6, your 6, your 6. Add them up, we get 24. But factorial is obviously a quick way to do this. Now, factorial, if we write n factorial, which is what we'll see a lot in high school math, n factorial, we don't know, say we don't know what n is, but n factorial, just let me get rid of that little exclamation mark, n factorial is n. So if it was 10, it'd be 10 by 9, which would be n minus 1, by 8, which will be n minus 2, and so on, all the way back to the number 1. So another way you may see factorial notation written. So make sure you have all of this down before we move on. So let's have a look at this surprising result. Normally in math, 0 is equal to 0 and nothing else will happen, but what about 0 factorial? So before trying it on your calculator, let's have a look here at the pattern going down this way. So pause the video and write this down. Okay, so how are we going from 120 to 24? We're dividing by 5. How are we going from 24 to 6? We're dividing by 4. This number, started with that one. From 6 to 2, we're dividing by 3. From 2 to 1, we're dividing by 2. So going from 1 to 0 factorial, we're going to divide by 1, and 1 divided by 1 is 1. So it's a little surprising result. Check it on your calculator. 0 factorial is equal to 1. Okay, so take this down before we look at the solution. Okay, so NPR, that's what this means, or how you say it, NPR. The number of ways of arranging n distinct objects, or at a time. So it maybe sounds confusing if it's the first time you've seen it, but it's really simple. In how many ways can the letters of the word ketchup, my favorite condiment, be arranged, taking 3 at a time with no repetitions allowed? So let's have a look here. We give them circles. How many letters in ketchup? 7. So how many choices have we got for the first letter? We have 7. Now we can't use that letter again, so we're just left with 6. And then we just have 5. And this is a multiply sum. 7 by 6 is 42, by 5 is 210. And if you type into your calculator, all good calculators have this function, 7 P or. Normally you'll have to use shift or second function, or being 3, 7p3, it will give 210. So NPR is also a formula you may see. N objects or at a time is equal to n factorial divided by n minus r factorial, which in this case will be 7 factorial divided by 7 minus 3 factorial, which is equal to 7 factorial over 4 factorial. And that's why it becomes 7 by 6 by 5, because on top we'd have 7 by 6 by 5 by 4 by 3 by 2 by 1 over, we line these up, 4 by 3 by 2 by 1. The 4's cancelled, the 3's cancelled, the 2's cancelled, the 1's cancels, and we're left with 7 by 6 by 5. Make sure you have this down before moving on. Okay, so the types of questions that can be asked. How many numbers between 500 and 1000 can be made from these 4 digits? 2, 4, 6, and 8. So what can we see? Well, it's going to have to start with, can't start with a 2 or a 4, so it's going to have to start with a 6 or an 8. So let's have a look here. If no digit can be repeated, we're going to start with a 6 or an 8, so there's 2 choices. And regardless of whether we use the 6 or the 8, there's going to be 3 numbers left. So in position 2, there's going to be 3 numbers left, which would leave 2 numbers for position 3. 2 by 3 is 6, by 2 is equal to 12. So that's the answer to question 1. Question 2, digits can be repeated. So again, we've 3 positions. It's a 3-digit number. They're multiplies. And we can see we still have 2 choices for position 1, but if they can be repeated, we have 4 numbers left. And 4 numbers left. 2 by 4 is 8 by 4 is 32. Next question, how many ways are there of arranging the word ketchup if there are no restrictions? So pause this video and try these questions. Okay, no restrictions. You're all telling me it's 7 factorial, which you've memorized from the beginning of the lesson, 5040. If it must begin with P, well, let's look at this position here. That's the first position. There's 1 option, which leaves 6 more letters. So the answer is 6 factorial, or 1 by 6 factorial, which is 720. If it must end with a vowel, well, here's the end point. Let's have a look at the end point. How many options for vowels are there? There's an E and there's a U. So there's 2 options at the end. And regardless of which option we use, this would leave 6 other letters, 7 letters in ketchup. So it's going to be 6 factorial by 2. And 6 factorial by 2 is 1440. So the 2 vowels must be kept together. Well, let's draw 7 little circles here. 1, 2, 3, 4, 5, 6, 7. So how many positions can the vowels be in? Well, they could be in box 1 and 2, box 2 and 3, box 3 and 4, box 4 and 5, 5 and 6, 6 and 7. So how many lines? We've 1, 2, 3, 4, 5, 6 lines. So there's 6 positions that they can be in. 6 positions. Within those 6 positions, the vowels can be in any order, and there's 2 possibilities, EU or UE, and then there's 5 boxes left when we just looking at the 2 boxes, and then there's 5 boxes left, which would be 5 factorial. So we have 6 by 2 by 5 factorial, which is 2 by 6 factorial again, which again is 1440. Similarly with TCH being together, you may see that there's just going to be 5 positions where TCH can be together. Let's just confirm that. 1, 2, 3, 4, 5, 6, and 7. Well, let's see. They can be in box 1, 2, and 3. Box 2, 3, and 4. 3, 4, and 5. 5, 6, and 7. So actually we only got 1, 2, 3, 4 lines. And hopefully you've identified that I did leave this one out. It is 5. So again, we have 5 positions. Within those 5 positions, there's 3 vowels. So that's 3 factorial. They can be arranged anyways. And if we have 3 vowels together, there's 4 boxes left. So we'd multiply by 4. So 3 factorial by 5 by 4 is 20 by 6, which is 120. Now, a really common question, the vowels must be kept apart. Now, this is the subtraction method, which I've written down here for you. Take this down. The number of ways an event does not occur is the total number of ways minus the number of ways that it can occur. Now, we know the total number of ways here, 7 factorial, is 5040. So that's the total number of ways. We've already worked out the number of places where the vowels are together, which was 1440. And if we take 1440 away from 5040, there's 3600 positions where the vowels are apart. The subtraction method. The last part of this video, probability 1, deals with when we have questions with n factorial or n simplifying. So we just need a little bit of knowledge here. N factorial over n minus 1 factorial. Now from earlier we said that n factorial was equal to n by n minus 1 by n minus 2 all the way back to the number 1. And n minus 1 factorial is obviously n minus 1 by n minus 2 all the way back to the number 1. So everything cancels apart from the n. So we're left with n. So a question that may look complicated, the math involved is straightforward. N plus 1 factorial, well, that's the number before n, so that's n plus 1 by n minus 1 all the way back to 1. And on the bottom we have n factorial, which is n by n minus 1 all the way back to 1. So what's left after we cancel? We just have n plus 1. Now this question, we have n on the outside, so we're going to multiply n by the first guy and n by the second guy, which is equal to n factorial over n minus 1 factorial, which we had in part 1, minus n factorial over n factorial, which is any number over itself. It's going to be 1, so we're left with the first answer, which was n minus 1. Now, whatever textbook you're using, go and practice some questions on probability 1.